All right. Okay, so I think we can get started. Uh, my name is Aziz Jamalian. I'm founder and CEO of The Giant Room. We are a creative STEM organization here based in New York City, and we work with schools all around the city in different in all 5 boroughs. And I'm really honored to be here to share part of our work with you, focused on computational thinking and game design, and how we think of it in the context of student-centered and interest-based, which actually aligns quite well to the wonderful keynote that we all heard today. There's this importance of understanding our students, who they are, where they're from, what are their interests, what do they like to bring to their classroom and to their learning journey, and how can we cultivate those interests and those joys and agency in our students, no matter what we teach. In this context, in this presentation, and the context of computational thinking and game design, but also hopefully in all of our practices. I'm going to share with you the presentation that I had here. So I'm not seeing any faces. It will be really, really helpful if you just like communicate in the chat area, and that like really helps me to not feel like I'm just talking to myself. And any question comes up, any feedback, any thoughts, any reflections, please let me know. And anywhere of the presentation that you wanted me to pause, I can pause, ask and answer any questions, or just engage in discussion. So hopefully we can do it both direction communication as much as we can. Here's my contact information, ozzy@thegiantroom.com, and our website. We're also on Instagram and LinkedIn. We try as much as we can to be active on those platforms. So if you are in any of those platforms, please join us there: Instagram, LinkedIn, and Twitter. Okay, so Giant Kids, from the first day that we started our work, we said we wanted to help kids build the world they want to live in. And the reason actually we called our space the Giant Room was that we wanted to give voice to kids with ambitious dreams, their giant dreams, and give them a confidence, a creative confidence to actually act on those ideas they have and start sharing their ideas with the world. And those sharings could be within their immediate community, in their classroom, but also with their broader community, families, teachers, and hopefully even outside of the school system, outside of the classrooms, to a wider community. And that's a way for us to show kids that they have their ideas and their dreams are worthy of sharing and making a difference. And they don't need to wait until they grow up to actually start making a change. They can practice this process of design thinking, problem solving, being aware of the world around themselves, and actually contribute to solutions that we're going to implement in our world from the age of 3 years old, 4 years old, 5 years old. So throughout the session, I'm going to come back to this mission quite often. Like, how can we give kids the platform to bring their own voices into their learning, and then how can we elevate their voices outside of the classroom? A little bit about me. I'm the founder and CEO of The Giant Room. I have years of experience, actually, both as a product designer. Before Giant Room, I was involved in 2 other tech startups, Tiggly and Little Bits. So, and through my work in those 2 companies, I worked with many educators, many district superintendents and administrators to think what are the best ways to start and scale a STEM program that is actually culturally inclusive, responsible, and sustainable. And through all this work, I've learned a lot from educators, and I'm always truly honored to be among the community of educators and learning more from what are the things that are working in their classrooms, and then what are the ways that we could learn from these best practices and share with other educators. So again, please use the chat to share your ideas. And Giant Room also has a co-founder, Jess Mazai, who we actually actually met at the grad school, and her background is in science education. And the reason we're bringing our backgrounds together is that our approach to STEM and computational thinking is always truly multidisciplinary. So it's always a little bit of science, computer science, a little bit of math, engineering, and technology. And I hope it reflects in some of the practices I'm going to share with you today. And one fun factor about us is that we actually started working together in a game design class at Teachers College. And the game we designed had nothing to do with our career or the things that we did after grad school. But this process of game design brought us together. So the topic today that I'm going to discuss is very dear to our hearts. Before we get started, please grab a piece of paper and draw 30 circles, or as many circles that you can, to fill your paper. And then I will tell you what we should do next. So this is a practice that we always start with almost all of our presentations, to put ourselves in a creative and maker mindset. So I'm just like drawing circles on a piece of paper. If you don't have a paper, just grab a napkin or whatever you can doodle on, fill it up with circles, and let's give ourselves 3 minutes or maybe 2 minutes and turn as many circles as you can to different things. So turn as many circles as you can to different things. We're going to come back together and we're going to share some of the things we made. Okay, let's start now. Usually I do this exercise with music on, but here I think it would have been a little bit complicated. So I'm gonna talk as I make it, so you know that I'm here and the session hasn't got disconnected. But the goal is to turn as many of the circles into different things as you can. And then we're going to share some of the things we made. Okay, and it's very interesting how many times I've done this exercise, but every time, depending on my mindset and what I think about, it actually different ideas come to my mind. And some ideas go away. Okay, we have 20 more seconds. Should I make this? Okay, let's start. All right, so I'm going to share some of the things I made, but then I'd love to hear some of the things that you created if you're sharing the chatting room. So here, when we do, so this is actually an exercise from IDEO. It's a design organization that they work with many different companies, and they have different workshops to cultivate creativity. And this is based on the idea of flexible thinking. What are all the different things that we could turn a single, like just a circle into, and depending again on our mindset and different context, we think, and our interests, we may think of a wide variety of categories. When we do this with our students, we get a lot of actually emojis sometimes. We've had once one student just turn all the circles in different emojis, which and they were done like before the 2 minutes. We once had a student that connected a series of circles and made it into a long caterpillar. And then depending on, sometimes we give them a context. We ask them to turn them to as many different food as they can. So in that case, we get lots of fruits, pizza, chocolate chip cookie, or you could think of it as a plate. All circles are as plates, and just like simply add any type of food that you wanted to put in, glasses, bicycles, and so on and so forth. I'm very curious to know what you thought to turn your circles into. But this exercise is a very good example of flexible thinking, but also it's a quick way of putting our students or whoever we're collaborating with in a creative mindset, and just like feeling that it's easy to share ideas. It doesn't matter how of a good drawer you are. You don't necessarily need to be a good artist or a creative person. It's just a matter of like quickly doodling, 2 minutes. No one can do a good job on drawing something in 2 minutes, like 30 different things in 2 minutes. But it's about the ideas that matters, and then hopefully after that, that communication of sharing ideas will know what are some of the things that our students are thinking about. And with that, we're going to start with our session focused on computational thinking, but in an unplugged way, and then we're going to connect it to game design. So one of the very first thing we always think about when we discuss computational thinking is the idea of using abstraction. So abstractions are formed by identifying patterns and extracting common features from specific examples to create generalizations. And the way we apply it in our work is thinking about the symbols that represent information, and how might our students use different types of symbols to represent the type of information that they like to communicate. Here is an example of one of our works with kindergarten students. We wanted to introduce them to the idea of block-based coding. But before they dived into actually coding on screens, we invited them to create their own blocks. And we were interested to to analyze their own designs, to understand what are some of the things that they like to make, and b, what type of symbols, what types of abstractions they use to communicate their information. And this work helped us when we started introducing them to code-based block-based coding, to know, will these students understand these symbols, or do we actually need to help them to make sense of the symbols before they even start doing the codes. So as you can see in this example, it's a wide variety of abstractions and symbols that our students use. Some of them, they were ready to start arrows, to basically use arrows to communicate movement, but majority of them actually were not there yet. The majority of them started using these like stick figures, or even like a little bit more elaborated drawings to show the type of actions that they like to code. So that you can see wide range of this abstraction and symbolism from our kindergarten students, that then we reflected on as we started introducing them to a more like advanced platforms. And this was also very helpful for us to understand some of the interests of our students. What are some of the things that they're thinking about? They were actually, in this particular class, they were really interested in dance movements and hip hop dance movements in particular, which again, kind of align with the keynote that we had previously. So you can see one of the examples, someone is standing on their head, people are standing on top of each other. They are doing like all these different sorts of dance movements that they wanted it to be translated into their hip hop sequence of dance that they wanted to show in the classroom. And then food was another particular exam, like of interest to these students. Here are some other examples. And you can see some students were ready to use arrows as a symbol of what they like to do. Some students, a majority of them, they will still using the stick figures to show the actions. And some others, they did more elaborated drawing. So they were not necessarily ready yet to the idea of using symbols to represent or to communicate information, which was one of the necessary things for us as we started showing them the coding platforms. And then you can see some of their interests. They wanted to talk about weather. You can see the rainbow up there. Again, lots of dance movements like split leg movement, jumping up and down. And they wanted to turn into a unicorn. They wanted to turn into a tornado. You could see the tornado dance note here. And you could see some of their day-to-day activities. So playing with the families, you could see the card on top right corner, sleeping on their bed, and just like they were keep thinking of different actions or different code blocks, quote unquote code blocks that they wanted to design that then used to code a classmate or a human robot, as we called it. Next is the idea of using these symbols in algorithms and programming to actually to programs that have sequences and simple loops, so that we can actually code a robot or a machine using our code like blocks that we design. And that was also a big opportunity for us to learn about how our students are thinking about these ideas of sequences and loops, but not only how they're thinking about the sequences and loops and actually using it in an unplugged way, how might they represent the idea of loops or sequences or number of times a certain event could happen in their own designs. So I'm going to show you how they added on their own blocks. And again, we introduced this before we go on the computer screen. We wanted to understand, does this idea of sequence one thing after the other make sense to students? Which students are ready? Which students are not ready yet? And how might they think about loops and in their communications? And starting using these computational thinking ideas and thinking processes in their language and in their way of communicating with other kids in their classrooms before they're trying to communicate these concepts with a computer. What we learned was that some students actually the idea of like they're gonna like sequence one after the other, it was kind of foreign to them. They were just like throwing these cards out of order, just like in front of the human robot, which in this case was me first acting as a robot, and not necessarily thinking of the sequence. And then after a couple of rounds, we started thinking, okay, how might we actually put these blocks in one row to communicate to our robot, so our robot knows what to do first and what to do next, and so on and so forth. And then the other idea that came up was as I was doing these actions, we started to ask questions of, okay, you want me to do the split leg, for example, action. How many times should I do it? How would you actually communicate that to me as your human robot? And that's how you see kids starting writing numbers on their blocks to communicate how many times they want something to happen. They also started talking about time, like time intervals that we wanted to. So some actions were about the number of times you would do it, and some actions were about like how long you would do it. And then we would talk about this, and I would use the language that we use in the computer as like a coding program. Like I will do it while, or let's start a timer and let's keep track of the timer. So these words became part of their language before we actually start showing them on a computer program. You can see like a number of different ways that they have it here. So 800 minutes, 100, some students weren't even ready yet to write numbers. So you can see like some backwards numbers, you see like the 300 there. And then we started talking about when should we stop, when should we start a particular action. So you see the cross on the block, on the purple block, that's how they thought about, like, that's how we're going to communicate with you to stop something, and then how to start something. So again, like all these different nuances that we wanted them to think about as they're thinking about like designing sequences and like a code in the computer program, they started internalizing in their language and coming up with their own way of representing those before they look at the blocks on a computer. Um, and this goes to the third part, that when we're talking about these algorithms and programming, we want to make sure that we talk about these loops, conditions, and event handlers. So while, if else, in the context that a 3-year-old, that a 5-year-old, 6-year-old would understand it before even they think of it as a way to communicate with the computer, but as a way to communicate with others, to be clear in terms of how they want to choreograph this dance movement that they wanted me to do. And one other thing that I'm going to add before going to the game design was that when we started the series, we didn't have any idea what we're going to code or what type of activity we're going to do. We made it completely open-ended, and it was kids who brought up their interests and their ideas to the session. But then we use our learning goals of introducing them to these concepts within whatever context they choose from. So their choice was hip hop dance movements, and they coded the human robot to do this series of dance. Another choice was different food items, so they wanted me like pretend eating different food. Another choice, it was like having a rainbow in your background and become a unicorn, dress up as a unicorn. So again, it was their interest, but using their agency in a way that basically as a catalyzer in their own learning journey. So they actually get excited. They actually do care how long I should do something, for how many minutes, how can they communicate with me to start something, to stop something, and so on and so forth. And for them to be very engaged in the program. And the same approach, then we take it to designing games. But before I start with designing games, I'm going to pause here to see if there are any reflections or any questions from our audience. Any thoughts? Any? Okay, great. So with the game design, we started usually a little bit after we think about the symbolism and these programming and sequences. But also it could be like a standalone program on its own. But the idea is again the same, thinking about some of the game mechanics that we could start introducing to our students to design their own games. But then if having them to, as they design these games, to think about a little bit more higher level of computational thinking skills in terms of like defining rules, designing and prototyping artifacts to play the game, to actually coming up with a mechanism to test these ideas they have, and then communicating the rules of the game for players so that they can follow and play. And then there's this idea of like playtesting, refining, and debugging to improve the games, which a lot of it then applies also to computational thinking. Some of the games that we design are basically paper prototypes or arcade games to again practice these ideas of coming up with your own rules and your own conditions and how to communicate those to the players. And then also the next step will be translating some of these games and some of these rules into different coding platforms depending on the skill sets and the grade level of our students. The first game mechanic that we always introduce, which we also very like a big fan of, because it's easy to introduce to different grade levels, and it's a very familiar game mechanics to especially early elementary educators, because we've always used dices in our storytelling practices. So that's a first go-to in our programs. With dices, we have our students to actually create their own dice. So it could be like a simple like traditional dice with numbers on all sides, or it could be a dice that they add different things that they want to add. So it could be different games, different food, or whatever they can think of, and then they roll the dice and they come up with a rule how to play, how to basically play a game with the dice that they have envisioned. And as they communicate the rules, we encourage them to write it down and try to be as clear as they can, so another group of participants actually play. And then we pause, a group of players play them, and the game designer just observe them to see how they rules translated, how their players understood the game rules, and then they refine either the game or the way they communicate the rules. So again, same practices that you would see in a coding practice, that you write the code, you run it, you see how the computer is actually following your the rules that you mentioned. But here it is actually in the context of unplugged with other students and other human beings. But it does not only it help them to be more clear in terms of those like defining the rules, but also be better communicators that would go much beyond just coding or computational thinking. These are some of the examples of what our students have came up with. Um, they used it to create dress up. So you could see that at the very left. So they would roll the game, and you had to use the different material we had in our studio to actually dress up and like that character. The one in the middle, it was actually for a storytelling game. So they would roll the game, and then the players had to basically come up with a character that the dice shows, and then they would roll again. That would change the background of the character. They would roll again. That would change like this the next thing that could happen in the story. And again, once we then translated this exercise to coding, that became like sprites and the backgrounds and the rules of the code as well. They also thought about like a magic 8 dice. So you could see maybe yes. And so these are all the different practices or the way of thinking that we want them to think about before actually going to the coding. Another game mechanic that we we reference often are the spinners. Here, again, starting with spinners with just like low tech materials. Here we have, you could create it with just like make spinners with paper fasteners by just like cardboard paper. In this case, we wanted to include some 3D printing. So you see like a 3D printed arrow, and also you can see a laser cut. So again, you could use different making tools and fabrication tools that you have access to, or you could just simply use cardboard paper to create your spinners, and coming up again with your rules. It could be a yes, no, a game of chance, or it could be like a storytelling game, or it could be like if the arrow points it to a certain animal, you have to act like that animal. Any rule that the child or the students come up with, and also any choices that they come up with. When we did it with our students, the choices they had were definitely not the things that we thought about. Here you can see some examples. Some are very actually detailed, and some they wanted to think about the food that they're gonna have, who they wanted to play with, what they want to do after school. So the choices and their interest and their agency were brought into this game, but the game mechanic was what was the thing that we introduced to them. And then from there, we took it to the same ideas. We used different types of making tools to actually create these prototypes of the games. So the same kind of curriculum and learning goals really applies from very young kids to all the way to even high school, depending on the tools that we give them access to make prototypes of these games. So I'm going to show you some examples on the left. There's this spinner game that one of our students made with a laser cut, and you could see the. So she wanted to create a math spinner game, and she actually drew all these nice designs for her spinner, and we use a laser cut to engrave it on the wood. And then at the bottom, we introduced her to DC motors and how we might use electronics to create a working spinner. So much more advanced in terms of making that, but again, the idea is as simple as what we introduced to very young kids through just arrows, like cardboard and paper fastener. In the middle is the same idea, another prototype that we use in our electronics class. So the idea of like multidisciplinary approach to electronics, science, coding, and computational thinking. Basically, we're all integrated. Here we use a DC motor. And then we also made a DIY switch with just aluminum foil to make our game. And then obviously you could go to use other coding platforms like Microbit that I know many schools that now have access to actually create these playable versions of their game with by coding devices. So here we made this like magic 8-ball using a Microbit in the background. Here are some other examples of how kids incorporated this idea of designing their games into communicate their ideas. The thing that was very nice here was that we encourage them to, once we introduce them to different types of game mechanics, we encourage them to design more complex games and more complex rules. And you can see they started writing those rules on a piece of paper by incorporating dices and spinners together, and also by collaborating among each other. So how might you design a game if you combine a dice that one student has created with a spinner that another student has created? What type of games you could design using these two different game tools. And also, again, a different variety of different tools you might have in your classroom. It could be as simple as using cardboard and a paper fastener and a box to create those, or it could be like integrating electronics, or in this case, we use little bits the fan as a DC motor, and so on and so forth, or Microbit if they are older and ready to start coding. And from there, we go also to more advanced game mechanics, which is always helpful to think about number of players, more complicated rules, and then it's a great way for us to start incorporating ideas about points and variables. So again, the symbol, as you can see on the dices, how they started to thinking about symbols as an abstraction of the ideas they want to present. So they mastered that idea, and then coming up with sequences and rules to use those artifacts to actually create a game, seeing coding their players by communicating the rules to their players, and seeing how they the communication of rules gets translated in a gameplay, and then going refining either the rules themselves, if the rules didn't make sense, or the way they communicate those rules. And then after they're comfortable with this exercises, then starting having more complicated games by combining game mechanics, challenging them to combine different artifacts, and then starting to bring the ideas of points and variables, which are more advanced computational thinking skills. And sport games are always a really like a great way for us to go to when we wanted to talk about winning or losing and keeping track of points. And it is something that most students could relate to because they have played some sort of games or sports in their real life. This is a low tech version of it. So we used here is like a paper that they actually design. You could cut it. We use a laser cut to cut it, but you could just use a scissors to cut it. It doesn't need to be anything fancy. And using modeling clay to actually create their players. So they had like these aluminum foils around their finger and designing these players. And so designing different parts of their games. And after that, what are the rules of the game, how are we going to take track of the points, and so on and so forth, and actually creating those point systems on the side so that we can then translate it into a coding game. And the games could be any games that they thought about. So we have some examples because it's a little bit more advanced. So we come up with some examples when we introduce this to kids, but then from there, it's really up to themselves. What are the type of games that they wanted to, like sports that they want to prototype, or who are the players, and what are the rules, and what is the pointing system, and so on and so forth. So in this case, they wanted to create a boxing game. So it's a traditional boxing game actually with your thumbs that you play, but then they created this like base for it and the players, and then they came up with the rules for it. So a little bit of a maker education, a little bit of computer science, and also lots of creativity and student agency going through the game design process. These are some other examples that kids made. So the ones that I showed you were the examples that we came up with and presented to them. And then it was basically an open floor for them to bring their ideas. And as you can see, they use just like paper and markers and very low tech material to actually create their prototypes. Some of them, they create similar type of games, but instead of soccer, they did basketball. You can see some others created their own game. So the one you see in the middle is a love triangle he came up with. So that's why there are like 3 players, and these 3 players need to compete against each other, which was quite funny. And they actually tried for 3 players to be able to put their thumbs um, in this board that he designed to play together. So lots of laughter, but also as they were playing, the game designer is always like sitting on the side, just trying to communicate the rules, and then just stop communicating and see how players are playing, and then coming back and refine the rules again to practice this idea of once you have the code out, you're going to run the program, you're going to see how it works, and then you go back to debug your communication. These are some other examples. It could be, again, any type of game or arcade game that you can think of that there's like some sort of a pointing system to start introducing the idea of variables. Here you can see a pinball machine. Everything is with the material that they have at home or in the classroom. This is another example of a foosball. Just straws and cardboard. And this is one other example, which I don't think is a video. And then as they were more comfortable with the idea of, okay, this is your first prototype of your game, now let's use more high-tech tools to create the next versions of your prototype, the next prototypes of your game. And then as throughout this prototyping process, then they would also learn new skills by like either it's electronics or coding on a computer science, but on a computer. But the computational thinking and the science behind these game designs were very similar along all these practices. And we didn't introduce kids to all of them at the same time, so not sit in front of the computer to design a whole game, but we gradually took them through this like prototyping process of what is your game, how do you actually communicate it? When you're happy with it, the next version of the prototype, and let's make a more fancier version with more high-tech tools, and then let's code it in a computer. And one of the things we highlight to our students is that this is actually the practice that basically designers in the real industry, like designers in industry designing real products, go through. They rarely start with coding something without any prototypes beforehand. They always try to have like a MVP, minimum viable product. They make that, they go and talk to their users, they try to see how their users interact with their design, and once they're happy with their design, then they translate that into a software that they can then scale. So the idea of like the design thinking and product design gets integrated as part of their practice as they design their own game, whatever game that is. So here we did the pinball machine with little bits. Again, it doesn't have to be whatever tools you have. It could be simpler electronics like DC motors or any other tools that you want to introduce to students. And on the right, you can see the boxing boxing game. This student is translating into a Scratch program. Another concept in game design that we think it translates very well. Actually, before I go to the next concept, I'm going to pause here. Any comments, any questions, any feedback? I'd love to hear your thoughts on any of these. All right, so another concept or another game mechanic that we go to quite often that we think it translates well to computational thinking skills are mazes and marble runs. And that's when we start integrating narratives and games together. So it has like planning steps and sequencing, but more advanced sequences, but also integrating stories and narratives as part of their games. And then the idea of level design, which is more advanced in designing their own video games. So the simplest ones are the ones that are just like have like steps and sequence and some rules. Then more advanced ones are the ones that have like variables and points. And then the third advanced type of video games are the ones that have levels. So different environments change based on those levels. And mazes and marble runs are great to introduce these concepts. So with mazes, again, in a true prototyping spirit, we always start with just like low-tech material. In this case, design a maze with paper and just like shoebox or a cardboard or whatever you can find. We've also, and I don't think I have it, actually I do. We have also done it with Lego. So again, like any type of material you have in the classroom, they could design their mazes. And then the way we would introduce the idea of integrating stories and narratives in their game, with their mazes, we always ask them to think about their marble as a character within the story that is in the game. So the first one you can see here is about this alien that wanted to go reach its planet. And along the way of this maze, there are some black holes. I don't know if you can see the little opening hole on the top left corner. So there are black holes that this alien needs to avoid, and then there are some loops that it just needs to avoid. They may reach the sun, which is too hot, and they have to go back. So they actually come up with those narratives that goes as part of their design, and then thinking about different power-ups and obstacles and different ways to start from a level within the narrative that they came up about. Again, the narrative could be anything that they can think of. We've had anything from anywhere from food, that this jelly wanted to reach the peanut butter sandwich, and they go through all these like hoops of monsters that they wanted to read it from these like people who want to escape from jail, and they go through all these like different hoops. So it could be honestly anything and everything, any story that kids wanted to bring into their marbles. But then within the story that they choose, they think about different power-ups, different obstacles, and then translate those into how it might represent into this marble run that they're designing. On the right, we have this other alien theme game, marble run. So just like different types of material with paper or with straws and modeling clay up to Lego, and so on and so forth. And then the other important thing is to think about when we start this, then we ask them about levels. How are they gonna introduce levels to their maze? Either they're gonna change the whole like maze background to make it more challenging, or what are the other ways that they could introduce challenges to their players. So in the middle, you can see some ideas that instead of having one marble ball, you have like multiple of them. And then they started adding like good marble runs that you definitely want them to reach the end, and bad marble runs that you don't want to reach the end. So that's the idea of like black marbles versus red marbles. We also had ideas of timer. So for them to think about how they're designing different levels, what variables they're introducing as they're designing levels, and how might it change the background of their game or the rules of the game. And the biggest, most important thing is for them to always write down their rules and keep track of these different ideas they have for each of the levels. So then when they're ready to code their mazes on the computer, they could go back to their notes and actually translate their own rules and their own the way they communicated into a coding platform. And then obviously the third piece is that it doesn't have to be just maze. They could actually incorporate different game mechanics that they learn. So in this case, this player incorporated maze, cards, and time. So as a timer, so different game tokens that we played with and we experimented with throughout the series, and then they brought it together to design these different levels for their maze. These are some other examples of what our students made. So sometimes when they're younger, this idea of maze and story is very new to them. So you could see more elaborated versions of their story. Again, the same ideas of how might we use symbols to communicate our ideas, or how might we make prototypes to tell a story. If they're younger, they're more concrete and more distinct, and as they get older, they start using symbols and representations to and abstracting their idea within a context of a maze. So you can see here on the left from a student that was younger, and you can see like bigger walls. Actually, each of those areas of their maze was just like an elaborated story that they wanted to tell, but then it became more and more abstract as students basically grew up. And in this case, we used cardboards, and I think these are hot glue to make the mazes. So whatever material they have in hand. Marbles mazes are one example. The marble runs are the other example that is very popular among kids. But again, the same idea. So the marble runs are great because there are there's a beginning and there's an ending, and you could think about conflicts and obstacles and power-ups within the context, but in a marble run, and your character going through different routes, and depending on which routes they go, different things could happen to the character. And even thinking about different endings. So it's another way for us to integrate the storytelling, level design, prototyping, and computational thinking within the context of game design. Marbles could be very simple by just using paper and tape on the wall. And one of the things that we really like is great because students keep coming back to them throughout. So like it's just, it could be something on the wall, and they could keep on adding to, so it doesn't have to happen in one sitting. And also they can incorporate many different types of materials. So the one in the middle, it's like all sorts of cardboard, paper cups, straws, and many different things that they thought about, or just in a smaller version on a piece of cardboard that you can see the dragon story. I'm going to share with you one video just so see when students were putting this together, the excitement when the marble run actually worked, and then translating that into their reflections as a computer scientist. Um, and this was after many rounds of actually trying. So this idea of being humble and actually going through this, like the whole process of like trying it, it doesn't work, then trying it, it doesn't work. So students actually do get to see that like even the instructors or the adults in the room don't have the answers, and it's all like through perseverance and like taking the risk and trying different ways to actually make it work. And then when it works, they get really excited, and they celebrate it together. And then once we're happy with our marble runs or mazes, the next step is to translate those into basically a digital game with whatever tool they are comfortable with at the time. We use Scratch quite often on Microbit, but again, it could be any coding platform. But the thinking and um, the logic behind their games has we designed it and we tested it and we prototyped it and we went through all those iterations before we translated into these like coding blocks to make a video games out of them. So this is one example of how they did it. But and again, you can see their codes become more complicated, and they're more actually excited to do it, or they're more willing to try these different ways of like how am I gonna add a timer, how might I add a variable, how might I do this, because they actually want to bring the rules of the games that they design into the computer game, and it doesn't feel like they're doing it because they have to do it, but they're doing it because that's how the only way they can communicate this game that they design, and they're excited to share. Another type of game that we go quite often to present it is their board games. And with board games, it's a great way for us to incorporate the culture of the classroom and actually thinking about the different types of problems that our students may be thinking about, and designing board games to actually thinking about strategies to solve those problems, or different types of ways that you could go about those problems. So here you get to learn a lot about, again, what our students are interested in and what are some of the problems they have in their mind and they want to focus as they're designing these strategies and solutions in their board game. It could start very simple. Here are rainbows and clouds, or this is like all the different ways to get to the concert hall. Or it could go into more serious problems that our students may be thinking about. The one in the middle is about climate change, that this student wanted to design this board game inspired by Monopoly, but focusing on climate change. And also to the right, you can see then students are starting like different, incorporating different types of game mechanics and even like different tools. So these students have is using LEDs and coin batteries to indicate the danger zone on the board game. So like incorporating their knowledge of electronics in their prototyping, and also using cards as part of that board game. Um, there's another one which we're running out of time, but I'm happy to share with you that we actually did in collaboration with Divas for Justice, the idea of like a board game design, and it was students who wanted to think about Black home ownership concept problem, and how might they design a board game to teach other students in their classrooms about pathways to home ownership as they play this board game, which was really a fantastic exercise for all of us to not only thinking about the problem, different ways that we want to support the community to learn about those pathways, and also practicing this computational thinking skills to translate our rules and what we would like to communicate. I'm happy to share that work if you're interested, if you email me. Here is a QR code to our portal. We share tons of different types of turnkey activities and videos with our educators, with educators in our community. We would love for you to join. It's completely free and just available to all educators, and we hope that you find them helpful. And here's our website and my contact information. Any questions or any thoughts? Yeah, it's thank you, Cara. Yeah, we really enjoyed when students start with using their paper prototypes. And one of the things for us when we are starting very low tech, we realize that we can actually focus more on the thinking processes and the concepts that we want them to teach, without them being distracted with the challenges of actually understanding what does this code block work and what does this coding language work. So they actually think about the concepts first, and then once they have a clear thought, then they graduate to the coding part. But yes, it's always very exciting to go through that process with students. Any? Thank you, Michael. We're lucky to have them. A lot of these things are honestly their ideas. We do a lot of things that they don't work, and they tell us within the first half an hour of the class that we're not really into this. So what the things that we're sharing has gone through the filter of our students, and they have contributed to the curriculum as much as we had. Thank you, though, for your kind note. Um, Okay, so we have one more minute. While we have this minute, I'm going to share with you, if there are no questions, I'm going to share actually this other program that I was talking about. We posted on our Instagram, and let me see if I can find it, because it was really a nice, and it is through Divas for Justice. A big shout out to them if you're interested to learn more about like board game design within the context of Black house ownership. They have a wonderful curriculum, which is, I think, is available on their website. And here is the photos from that. Let me share that with you. So they came up with a board game, and they actually 3D printed all their tokens. So it was incorporated a 3D design, laser cutting. They laser cutted their board once they were happy with it, and this was the final prototype of their game. And you can see throughout, like they talked about different concepts of mortgage designs, like different how to choose the neighborhood, like all the different component that goes through the path for homeownership and saving, reflecting on those ideas, and also practicing their tech skills, working with 3D printer and computational skills when they translate it into. Yeah, so this is their first prototype with the paper. And these were middle school students. So again, showing that the same ideas could translate from younger students all the way to high school, depending on the tools that we provide to them and also the concepts that they want to focus on. Great. Thank you so much for joining. Please stay connected. I love to hear about some of the practices you bring into your classroom, and I'm sure we can learn a lot.